Right now, an object older than the Sun is flying out of our solar system, and nothing we have can catch it. It came from another star. It will never come back. And its chemistry is unlike anything we have ever measured. Its name is 3I Atlas, and it is only the third interstellar visitor humanity has ever caught passing through. On July 1, 2025, a survey telescope in Rio Hurtado, Chile flagged a faint smudge moving impossibly fast. It was clocked at 137,000 miles per hour, far too fast to belong to the Sun. At that speed, the Sun's gravity cannot hold it. Its path is a hyperbola. One pass through, then gone forever. The Hubble telescope sized its frozen core at somewhere between 1,400 feet and 3.5 miles across. A mountain of ancient ice, wrapped in a glowing cloud of gas and dust, crossing our neighborhood exactly once. Within weeks, nearly every major telescope on Earth and in space had turned to stare at the stranger. And what they found in its light made the discovery itself look ordinary. But first, meet the two visitors before it. In 2017, a cigar-shaped object named Oumuamua tore through the solar system and left astronomers with a mystery. As it left, Oumuamua sped up slightly, and gravity alone could not explain why. That mystery is still unsettled. 2 years later came Borisov, a comet from another star that looked almost disappointingly normal as it passed us. That was the entire catalog of interstellar visitors. 2 objects, in all of recorded human history. Then came the third. The 3I in 3I Atlas simply means third interstellar. It joined the shortest, strangest list in astronomy. Each visitor is a free sample from another solar system, delivered to our doorstep without a return address. Building a spacecraft to fetch a sample from another star would take tens of thousands of years of travel. These objects make the trip for us. The catch is that they pass through fast, and they never slow down. Astronomers had one shot, a few months long, to learn everything this visitor could possibly tell us. So they pointed everything they had at it. And the light that came back broke the first rule of comets. A comet's glow is a chemical fingerprint. Every element it boils off bends light in its own signature way. 3 Atlas was venting carbon dioxide, water, carbon monoxide, carbonyl sulfide, and grains of ice as sunlight warmed it. Ordinary enough. Then the James Webb Space Telescope looked closer, and one number came back deeply wrong. Its methane to water ratio measured roughly 11 times higher than any object ever recorded in our solar system. 11 times. Not a rounding error. This comet was built from a recipe our solar system does not use. In Chile, the Very Large Telescope weighed its carbon and nitrogen atoms for another clue. Their isotope ratios. The nitrogen said it formed far from its parent star, in the cold outer edges of another planetary system. The carbon said something stranger. Its birth star was ancient, poor in heavy elements, from an earlier cosmic era. Every measurement pointed the same direction. This thing was not just from far away. It was from long ago. The question stopped being where it came from, and became when. The answer is hard to hold in your head. Using the Webb data, scientists put the age of 3I Atlas between 10 and 12 billion years old. Our Sun is about 4.6 billion years old. This comet is more than twice its age. It likely froze solid before the Sun existed, before the Earth existed, before any planet you have ever seen. When it formed, the universe itself was young, and the galaxy was still assembling its first generations of stars. Then its home system let it go, and it began to drift. Not for centuries, for billions of years. It crossed the galaxy through cold and dark while the Sun ignited, the planets formed, and life began here. Dinosaurs rose and vanished while it drifted. Ice ages came and went. It just kept falling through the dark. By pure chance, its ancient path finally intersected ours in the summer of 2025. We happened to be watching. A 10-billion-year-old message in a bottle, washing through our solar system at 250,000 kilometers per hour. Which raises the obvious question. If this thing is so precious, why didn't we just send a spacecraft to it? The European Space Agency answered bluntly. It was far too soon, and the comet was moving far too quickly. By perihelion, its closest pass by the Sun in late October 2025, it hit 153,000 miles per hour. It passed just outside the orbit of Mars, and never came closer than 170 million miles to Earth. Spacecraft take years to design, build, and launch. This visitor gave us months of warning, moving faster than anything we fly. So instead of chasing it, humanity did something remarkable. It turned its entire existing fleet into an ambush. Hubble and Webb watched from near Earth. Mars Express and the ExoMars orbiter caught it passing the red planet. The JUICE spacecraft, the Sunwatcher SOHO, and 2 X-ray telescopes all joined in. 9 observatories tracking 1 visitor. And for the next one, there is a plan. Europe's Comet interceptor will launch and simply wait in space. It is designed to ambush a pristine comet from the outer reaches, and could, just possibly, catch an interstellar one. 3I Atlas will be long gone by then. So what? In the end, did it actually leave us? It is leaving now, at the same speed it arrived, already too faint for amateur telescopes to find. It will fall back into the dark between the stars and, in all likelihood, never pass another living thing. But it left behind proof that other solar systems build comets from ice and dust, much like ours does. It left a recipe, that strange methane signature, from a star that died before ours was even born. And it left a lesson. Visitors like this are not once-and-forever events. 3 have passed in 9 years. Better telescopes are coming online, and each one raises the odds of catching the next visitor earlier. Somewhere out there right now, the 4th one is already falling toward us. It has been falling for eons. When it arrives, we may finally be waiting with a spacecraft, instead of just watching it go. An object older than the Sun crossed our sky, and the universe felt, briefly, like a neighborhood. And the first visitor, Oumuamua, the one that accelerated on its way out? That mystery is a story of its own.